Leetcode question 460, LFU cache. Design and implement a data structure for a least frequently used LFU cache. Implement the LFU cache. Initialize object with the capacity of the data structure. Guess the value of the key if the key exists in the cache, otherwise return -1. Put, update the value of the key if present, or insert the key if not already present. When the cache reaches its capacity, it should invalidate and remove the least frequently used key before inserting a new item. For this problem, when there is a tie, that is, 2 or more keys with the same frequency, the least recently used key would be invalidated. To determine the least frequently used key, a use counter is maintained for each key in the cache. The key with the smallest use counter is the least frequently used key. When a key is first inserted into the cache, its use counter is set to 1 due to the put operation. The use counter for a key in the cache is incremented. Either a get or put operation is called on it. The function get and put must run in O1 average time complexity. Let's take a look at the example. We initialize new LFU cache with capacity of 2. We put key 1 value 1, and then we put key 2 value 2, and now we reach the capacity. When we call get 1, we return the corresponding value for key 1, and then we increase the counter for key 1 by 1. And then we call put 3. In this case, since it's already at capacity, and then we invalidate the least frequently used, which is the value with key equals to 2. So we invalidate that. So now the cache is 3 and 1. 3 is used once, and then the key 1 is used twice. Get 2, return -1 because not found. Get 3, return 3, and increase the counter, the use counter for key equals 3. And then call put 4. Both 1 and 3 have the same count. Since 1 is the least recently used, invalidate 1. And now the cache contains the key 4 and the key 3. Call get 1 returns -1, get 3 returns 3, increase the use counter for key 3. Get 4, return 4, increase the use counter for key 4. So for this one, it's actually the LFU cache. But if there's a tie, we also need to implement LRU cache. So the idea for solving this. So first question I'm going to ask is, what do we need to track? Because this is a fairly complicated problem to solve. We need to track the capacity. That is, what the capacity of the cache, and then whether cache reached capacity or not. If it reached capacity, we need to remove the LFU least frequently used key before we can put the new key and value. And then we also need to track the use counter. Basically for each key, we need to increase by either get or put operations. We also need to track the LFU count. So basically, what is the count for the least frequently used key? We also need to track the least recently used. So basically for each frequency, for all the keys with the same frequency, we need to track the least recently used. And then we also need to track the corresponding key and the value when we put the key and the value onto the cache. So those are the information we need to track. So in order to implement that, we need to have a self frequency. That's the hash map. We count the key is the key, and then the value is the count for each key. We also need to track the capacity. That is the capacity of this LFU cache. We also need to track the LFU count. That is the frequency of the least frequently used key. We also need to have a least recently used, basically for keys with the same frequency. That is also a hash map. The key is the count, that is the frequency, and then value is doubly linked the list of keys with this count. That's kind of recall what we implemented in the LRU cache. So basically, LRU is a hash map, the key is the frequency, and then the values are all the keys with that frequency. But when we track it, we actually put them in a doubly linked list in order to support the list recently used. So in order to track the key and the value, we kind of have two options. Option 1 is store both key and value in the linked list node in this LRU above. The second option is only store keys in the linked list node. Store key and value in a hash map. The hash map is called self.cache, with key equals to key and value equals to value. And then if we are doing it this way, we can easily track whether or not we reach the capacity by calling line self.cache. So in this case, we are just going to implement the second option to track the key and the value put onto the cache. So how to implement the doubly linked list that's supporting LRU? You can also view my LRU cache Leetcode question video for details, but here we're just going to implement a relatively simplified version of that. We use two pointers, left and right pointers, which are commonly used for the linked list problem. We have a node after the left pointer, that is the least recently used, and node before the right pointer, that's the most recently used. So basically, we delete the node after the left pointer, and then we insert node right before the right pointer. How to locate the node in O1? So basically, we have a hash map. The key of the hash map is just key. Value is the corresponding node in the linked list. So that's what we implement for this LRU. For this LRU, it has two pointers. It also has its own hash map to track the key and then the corresponding node in the linked list. Okay, for the method for this doubly linked list, we cannot append. When we append a node to the right side of the linked list, we delete a node from any location in the linked list. And then also pop left, remove key from the left side of the linked list to remove list recently used when there is a type for the LFU. For the delete, why we need to delete from any location? Because let's say if we call a put or get, let's say when the LFU cache not reaching the capacity, but we call the put or get operation for a key previously inserted. In that case, we need to update the use counter, and we also need to make that key the most frequently used, the most recently used. So in that case, we need to delete that node from the original location and then insert right before the right pointer to make it the most recently used node. So that's why when we implement delete, we delete a node from any location in the linked list. Okay, so this is kind of the idea for solving this. This is quite complicated, so let's actually implement the code. So we first have the linked list node, and then after that, we also need to write a class for the LRU. For the node, let's define. So it's the key self, and then key is, let's say, default value -1, and then previous, and then next. This is our linked list node. And then we have a LFU cache, LRU cache. So let's implement the list recently used. So we need a self.left. We need a left node, that is left pointer, that is the node. And we also need a self.right, that's also node. And then initially we connect them together. So self left the next is just self.right, self.right previous is just self.left. And then we also need a hash map. So self.cache for the LRU. So the key is the key, and then the value is the linked list node. So in that way, we can quickly locate the corresponding node for a given key. And then we need to implement the method. So append, and then let's define delete, define pop left. So those three methods we specified. So append given key value. So in pass. So let's first implement the append. So basically, to the append to the end of linked list. So we append to the end of this linked list. So we first create a node called the node key value, a node key. And then previous is just self.write previous, and then the next node is self.write, and then node self.write previous, next is just this node, self.write previous is just this node. So basically we are just inserted a node before the self.write. We also need to update self.cache key, just this node. And delete, let's delete a key, the node corresponding to that key. So when we append, we actually just append that key. And then let's delete. So for the delete function, so the node for delete is in self-cache key. And then we can only delete if key in if key in this cache, then we just delete it. The node we are going to delete is this node, self.cache key. And then we get previous, and then next is just node.previous, node.next. And then for delete this node, we just have previous.next is just next. Next previous is just this previous. And then after that, we delete this self-cache key. We delete this one from the hash map. And then let's implement the pop left. So we pop a node from the start of the linked list. That is our least recently used one. So basically what we are trying to do is actually delete the self.left.next. So that's the node we are going to delete. So in that case, we call the pop left. So that's a node we are going to delete. So to pop the left, so self.left.next. So in that case, we can just simply delete by self.next. It just equals self.left.next next. Or what we can do is we can actually call the delete function. So basically self.delete self.left.next.the key. So result self.left.next.value. And then we delete, and then we just return the results. And then if self.left.next.next. So basically for this one, let me put it this way. So that is, okay, want to make sure that self.left.next is not self.right. So that's the result we are returning is actually the key. So that's our least recently used. So now let's implement the LFU cache. So for the initialize, That's why I'm writing it down, the idea for solving it first, because this question is very long. So, okay, so now those are what I need to track. So I need to have a self.LFU count. Initially, it's set to 0, self.capacity, it's just the capacity. And then we also have the self.LFU, LRU. So let's do a default dictionary. So from collections, import default dictionary. And then for the default dictionary, that's just default dictionary, LRU. And then we also need to have a self.cache. We also need to have the self frequency. Let's do default dictionary hint. In this case, the key is the value. So the key is the key, value is the count for each key. So let's see if we miss anything. Okay, so we have self.frequency, capacity, LFU count, LRU, and then we also store the key and the value. We need to track and update the use counter. So this use counter increased by get or put operations. So basically, here for this class, it has get and put. And then we also need to have a counter function. Basically, that's called by both the get and put operations to increase the count. So in that case, we need to have a counter function. So it's a private method to the class. Okay, so now let's see what's happening when we are trying to put an element. So when we're trying to put, we first check if reach capacity. If cache is at capacity. If it's at capacity, we first invalidate the element, and then we kind of insert. But we also need to check if key not in cache and cache is at capacity. That is because if the cache is at capacity, but this key is already exists in the cache, we just need to update the value. In that case, we do not need to invalidate anything. So in that case, we check, if key in self.cache and length self.cache is greater than or equal to self.capacity. So in that case, we need to actually invalidate and remove LFU key. So in that case, invalidate and remove the LFU key. If there is a tie, this also involves LRU. If tie LRU. So basically, we need to get what is the least frequently used key. So basically, this one self.lru self.lfu count. This actually gives us the linked list that contains all the keys with the least frequently used count. And then for this one, we just need to remove, basically delete. We call this method. This gives us the LRU class. And then we call the delete. Okay. So delete. And then what is the key to delete? Self dot. That is pop left. And then we also need to get the key for pop left. LFU key. And then when we get the key, we kind of self dot because we need to update frequency. We also need to update the cache. And then we also need to update self.lfu count. In that case, we need to know how many elements left after we pop this node from the LRU. So in that case, for the LRU, we actually need to implement another method to get the length. So here, I'm going back to my LRU class. So define the length of LRU. That is, just return the length of self.cache here. That's the cache for this LRU. So I only need to update this one if self LRU self.lfu count the length so there is no elements left. Okay, if there is no elements left, then we need to update the LFU count. To update the LFU count, we need to actually, let's say, currently we are at this LFU count. And then when we update it, we need to know what is the next least frequently used. Okay, this key in the self.cache, the newly inserted key. So basically, we invited and removed this LFU key. If Ty removed LRU, so we pop this key from the left. So we remove the least frequently used with this LFU count. And then we are trying to update frequency table and then also the cache table as well. And then also delete that from the cache. And then if the length, let's say, there is no other key with this least frequently used count available. In that case, we need to update this self.lfu count. So what are we updating it to? So that is, let me see. Okay, let me leave a to-do here. We need to update this one. And then let me see. So we track the self.frequency for each value. So the least recently used count, least frequently used count. Okay, what is the next least recently used? And then let's say if we already implement this one, then we need to insert this key. So this is either not key not in cache or key is in cache. So in that case, we kind of self.lru. Actually, so self.frequency. So basically, we call the use counter self.counter, and then call this on this key to update it. So in this counter, it should update the frequency. And then after that, we should call self.frequency for this key. We get the corresponding frequency, and then this is our count. And then let's say if in this counter we update its frequency, in that case we'll also need to put it in the right location. So basically, and then update is in the corresponding frequency table. And then after that, we just need self.cache key, it's just this value. So this is our put operation. And then for get, so I'm going to go back and visit this put operation about the part for update this self.lfu count. So for get operation, we need to update the counter for this key, that's for sure. And then we need to return self.cache key. So in that case, if key not in self.cache, we just return -1. Else, we update the counter and return self.cache key. So that's really simple. So now let's implement this counter before we go back and visit this put operation. So there are several things we need to update in this counter. We need to update self.frequency for this key. We also need to update, okay, count. We also need to update self.lru. Self.lru, self. So basically, let's get the count. Self.lru count, we need to actually delete this node. And then we need to self.lru count +1 append this key. That is, when we update the counter for this key, we increase the frequency by 1. We first retrieve its original frequency, and then we increase it by 1, and then update it in the frequency table. Basically, this self.frequency stores the key and then the corresponding count of the keys. And then we also need to update the self.lru. So we first need to remove that node from the original count. And then after that, we need to actually insert this node to the updated count. And then after that, we need to update the self.lfu count. That is if self.lru count .length is 0, no elements left. In that case, self.lfu count increase by 1. Why increase by 1? Let me see. Not increase by 1. And So basically, let's check this one. Okay, so let's say if LFU count is just this count, and then we delete this key from the count, and if after delete there's no other elements with this count, in that case we need to update this one by 1. That is, okay, the key we are trying to update this counter for is the least frequently used key. So in that case, when we increase its counter by 1, increase the count of this key by 1, we also need to increase the LFU count if there is no other key with the LFU count. If this is the only key, if this is the only least frequently used key, and then we already update the counter for this key, then we need to update the least frequently used count. If this key is the least frequently used key, but there are also other keys least frequently used, in that case we do not need to update the counter. So that's why those are two conditions that we have to met in order to update the counter. And okay, let's go back and revisit this part. I just realized I made a mistake. So when I write on line 112, check the key not in cache, and cache is capacity. But on my code is actually, I forgot to, let's say, write not in cache. So if this key not in cache, so actually we do not need to worry about this one. The reason why we do not need to worry about this one is, let's say we already delete the least frequently used key. However, this newly put key is not in the cache. So in this case, it's just going to be inserted into the cache. So the frequency for this key, newly inserted key, is going to be the least recently used, the least frequently used key. So in this part, we just need to invalidate and remove the least frequently used key. So in that case, we pop the least frequently used key from the LRU, basically from all the nodes with that frequency, and then we delete it in the corresponding frequency hash map and then cache hash map. And then we just insert and then update. And then here we just going to add a condition in the counter. Let's say in the counter for newly inserted key, that is if key not in cache, so that is for newly inserted key. If this key is not in cache before, in that case, we just insert it, or we just get the LFU count to this key. Or we can write it this way. It's just the minimum of the self frequency key, and then also the self LFU count. Okay, so this is actually the entire solution. Let me try run it. Okay, this solution is accepted. Let's go over the solution one more time since it's fairly complicated. So basically, this is a combination of both the LFU and LRU. Basically, LRU is handled, let's say, for the key with the same frequency, they are put in a LRU. So for the implementation, we have the frequency, count frequency for each key, capacity, check if it has reached the capacity, and then the LFU count, what is the frequency of the least frequently used key. And then we also have LRU hash map, the key is the count, the frequency, and the value is a doubly linked list of keys with this frequency that support the least recently used. And then for store the key and value, we also have a self.cache with key as key, value is the corresponding value. And then for the doubly linked list supporting LRU, that's very similar to what we did in the previous Leetcode question, LRU cache. I have a video for that, you can go and check on my YouTube channel. But basically the idea is 2 pointers, left and right, indicates the start and end. And then we also have a hash map key, and the value is the corresponding nodes to quickly locate a node in the linked list in one time. So, and then for the LFU cache, so basically we have a counter. This because a counter is a commonly used function by both get and put operation. So basically the idea is, okay, when we have a key, we first get this key. Basically for this counter, we are just trying to increase the count of this key by 1. We first fetch the existing count, the current count, increase by 1, update in the frequency table, and then we need to update in the self.lru. Basically, we delete it from the previous frequency, and then insert into the linked list with the updated frequency. So that's what these 2 lines does. And then after that, we need to update the self.lfu count. That is, okay, if this key was previously the only LFU key, in that case, when we increase its frequency, we need to increase the LFU count by 1. And then if this key is newly inserted key, so in that case, we need to update LFU count to be the minimum of the frequency of this key, and then also the original LFU count. And then for the get operation, it's pretty simple. We first check if this key is in self.cache. That's another reason why we want to use a cache to actually store the key and the value. So if key not in this cache, we just return -1. And then we update the counter by 1. We call self.counter. And then we return the corresponding cache value. For put, we need to first check if the key is not in cache and the cache is at capacity. In that case, we need to invalidate and remove the LFU key. If the key is in cache, then we just update, then we do not need to remove LFU. Or if the cache is below capacity, we do not need to invalidate and remove the least frequently used key. So if we need to remove the least frequently used, basically we get the corresponding key from the count. Remember, self.lru is a hash map with the key is with frequency as key, and then the corresponding linked list that stores all the values, all the key value pairs with that frequency. So in that case, we get the corresponding key, the key with the LFU count. And then after we get that count, we delete it from the frequency hash map and then the cache hash map. Remember, when we pop left, we already popped that key. And then we insert or update this new key. We increase the counter, update the counter, and then put in the self.cache. So this is our entire solution.